They will link their biggest city, Zurich, to Milan in northern Italy. From 2017, high-speed trains will make the 200-kilometer trip faster than an aeroplane. But to make this happen, the Swiss must overcome a huge obstacle. They must break through the Gotthard Massif, towering over 2 kilometers above. If anyone can do it, it's the Swiss. They have turned tunneling into a fine art. For the last 13 years, men and machines have been working round the clock to build their masterpiece, the Gotthard Base Tunnel. To understand how the Gotthard Base Tunnel can be this big, we must travel back in time. In the 19th century, London engineers wanted to build the world's first underwater tunnel beneath the River Thames. But first, they would have to stop the weight of the river from crushing it. Traffic problems in London are nothing new. It may seem bad today, but it was even worse 200 years ago.
In the 1800s, this is the busiest port in the world by miles. Britain is a dominant imperial force and all its trade, or most of its trade, comes through the port of London. This thing is stacked 20 deep with tall-masted ships going across the river. So bad is it, in fact, that to get your freight from one side to the other could take you longer than putting it on a cart and taking it to Scotland.
The trouble is that the bridges across the Thames are badly congested, and building new ones just isn't an option.
You want to get from one side to the other, and bridges are really difficult. They're difficult here because you've got tall-masted vessels, and to get underneath the bridge has got to be up really, really high, and the approach ramps will end up being miles long.
A bridge is not the answer. Then a French engineer called Marc Brunel has a vision: a tunnel under the Thames. But Brunel knows that digging such a tunnel is fraught with danger, as the ground under the Thames is extremely treacherous.
Here we have the Thames in a jar, or a fish tank, to be more precise. And what we see is the River Thames looking suitably murky, and on the bottom of the Thames, alluvial sands and gravels and things like that. Underneath that, we've got a layer of clay, and that's good stuff to tunnel through. It's the stuff we want to find. The challenge for a tunneler is to stay within the good tunnelling ground. If you drift too far out of it, you're in trouble. So, let's have a go with our tunnelling device, shall we? I'm going to try and stay within the white band, which is our clay band. Oh, and we can see the water coming in there. So I've bust through, and there we go. Welcome to the River Thames.
But Marc Brunel thinks he has the solution. He finds inspiration in an unlikely place.
Marc Brunel is working in the Chatham Dockyard, and he's working in a land of wood. Ships are made out of wood, and he notices that there's a little mollusk called the shipworm that burrows its way into timber. But he's struck by how does the shipworm do this, and why doesn't the tunnel squeeze in on them afterwards?
The shipworm is a clam that wears its shells on its head. The shells have serrated edges. They can cut through even the toughest wood as the shipworm pushes forward. But there's a problem. Wet wood swells over time. This could close the tunnel and squash the animal. So the shipworm has a clever trick to stop this from happening. It secretes a slimy substance that hardens into a tough protective shell around its soft body. As the shipworm advances, the rigid lining keeps the tunnel from collapsing.
What Brunel does is what lots of people have done through time, is they've found a problem that looked just like theirs and realised that if they can replicate the key parts, they can use the solution somewhere else. And here he's figured out that the shipworm is actually solving the same problem as him. It's boring through something that wants to squash down afterwards.
Mark Brunel builds a machine that uses the tricks of the shipworm on a huge scale. He calls it the tunneling shield. The machine is made of 36 iron frames that each hold one miner. Wooden boards shield them from the unstable workface. They remove one board at a time and dig out 10 centimeters of mud. Once they've taken away a whole layer of mud, they use jacks to push the frame forward. This exposes a narrow gap of unsupported mud. Like the shipworm, Brunel immediately lines the passage before it collapses. He uses bricks and extra strong cement to create a sturdy twin-bore tunnel. This machine becomes the key to tunneling under the Thames. Brunel's Thames tunnel survives to this day, but it shows no trace of the horrors that the workers endured to build it.
Where we are now is at the bottom of the Rotherhithe shaft. And the men would have come down from Rotherhithe every day, and they would have climbed up the ladders onto the shield with their picks and shovels, and away they would have gone. And at the beginning, I imagine it was pretty much okay. They'd have been figuring out how to use the shield, but, you know, the ground here isn't that bad. But once they got down into the middle, it would have been a pretty hairy business, especially once they got right underneath the river.
Brunel's shield stops the tunnel from collapsing, but it offers no protection from the filth under the River Thames, which in those days is an open sewer.
They can only work for 2 hours at a time because methane is being released from all this rotting crap on the bottom of the Thames. And some of them will be getting sick. So they would be taken to the back, slapped about a bit, they'd revive, and they'd go back and do another shift. They're desperate stuff. I mean, the stuff they're digging through at its worst is so horrible it'll rot your fingernails.
Today, it takes only 45 seconds to travel through the tunnel that took Brunel's team 12 years of toil to build. And they couldn't have done it without his mechanical mollusk. Brunel's idea was so brilliant that the principle is still used today on the Gotthard base tunnel. The team working at the face also strengthened the tunnel walls immediately. Only instead of bricks, they spray on a special concrete that hardens extremely quickly. It's called shotcrete. The shotcrete forms a stiff tube around the tunnel that stops it from caving in on the workers. It is the ultimate reincarnation of Brunel's mechanical shipworm. But sometimes the ground the team are tunneling through is so treacherous that the shotcrete alone can't do the job.
We are drilling the tunnel in very bad geological condition. You can see here the quality of the rock. It is soft rock, and this rock will close. It is a squeezing rock.
The soft, squeezing rock could easily bring down the tunnel, so the engineers must strengthen it with steel arches. But to survive the force of the mountain pressing down, these arches have to be very special. If the engineers used arches made from long steel beams, the crushing pressure from the mountain could prove too much for them. So they use arches made of many short segments. Each segment overlaps with its neighbor. They're tied together with steel clamps that still allow them to slide over one another. As the mountain squeezes down on the arches, friction between the arch segments gets stronger until they finally lock together. And once the mountain settles, the arches are secured with shotcrete. The engineers of the Gotthard have learned their lesson. The key to stopping their tunnel from collapsing is not to fight the mountain, but move with it.
Tomorrow on Great Migrations, they are driven by an insatiable appetite to survive. An arduous journey that is truly feast or famine. Great Migrations, tomorrow at 10 p.m. on the National Geographic Channel. Co-presented by Panasonic Viera 3D TV in association with UPS, AsianPaints.com and multiplex partner PVR Cinemas.
I go the boom boom way. Watch me go the boom way.
रूप तेरा मस्ताना प्यार मेरा दीवाना
Now, flip your mood in 4 different ways with Flipside shower heads from Kohler.
हेलो
क्या आप मोटापे से परेशान हैं? कपड़े टाइट हैं? आपको चाहिए स्लिम सोना बेल्ट? 30 दिनों में
नो
मोटापा
थैंक्स
वेलकम।
पेश है स्पाइस वीडियो फोन बिग बैटरी के साथ। अब पिक्चर देखिए बिना रुकावट। वेल ऑलमोस्ट।
When you're in trouble, alone and blue,
Mr. HCL.
just look around.
Light and airspeed help that.
Yes,
And I'll be waiting for you.
HCL's aerospace solutions help the most advanced aircraft take flight. Technology that touches lives.
Reverse the effect of rain. Weather coat All Guard exterior paint with silicone that actually pushes water away. Truly durable.
लाया तो था शेयर करने पर। Hey, come. Guys, छुपा रहा था।
ओए चौका उधर देख यार, उधर देख। ये पक्का कैच नहीं पकड़ा कैच।
अबे वो तो बैट कर रहा है ना।
जब लेस का बिग सेव पैक हो तो दोस्तों से क्या सेव करना, शेयर करो।
Lays Bidil, logical.
Launch offer. Get 20% extra with Lay's ₹13 big save pack.
Get away from the concrete jungle. Be the first to experience the Skoda Yeti in the wild. It is your right of way. Skoda Yeti presents the Right of Way Expedition in association with National Geographic Channel. Explore, photograph and learn with a leading Nat Geo photographer. Come be a part of the unforgettable expedition. It is your chance to drive where the roads end. Brought to you by Skoda Auto, obsessed with quality since 1895.
Great service. Great people. Great fares. Visit CathayPacific.com.
In 1825, Brunel's tunneling shield revolutionized engineering. But excavation was still done by hand and was painfully slow. To take the next leap in tunneling evolution, engineers had to overcome this problem. build the much longer 3-kilometer box tunnel through solid limestone, they would have to find a faster way to excavate. In 1833, the Port of Bristol decided to build a railway line to London to boost trade. And the man they picked to do the job is Marc Brunel's son, Isambard.
This guy is so ambitious, it defies belief. I mean, he's in his late 20s and he goes for the biggest railway gig in the land. You know, not a small thing. He's 25, 30 years old. He is going to build the most speedy, comfortable railway ever seen.
Brunel surveys a 200-kilometer route on the flattest possible path between London and Bristol. But just before the end, he faces a formidable obstacle: Box Hill. If Brunel lays his track up and over the hill, the slope will be too steep to climb. If he lays the track around the hill, the detour becomes too long. So Brunel chooses the third option. His trains will go right through Box Hill in a tunnel. Box Hill is made of limestone, which is very hard to dig through with picks and shovels. So to speed things up, Brunel decides to borrow a technique from the military. He will use gunpowder to wage war on the mountain. Explosives engineer Sidney Alford will demonstrate the devastating effect of a small amount of gunpowder on limestone.
I've got here 6 ounces of powder. This is very, very important stuff and was extremely important in the operations that Brunel directed. What you must not do when compressing it in the hole is to use a steel tool, because if you have any sparks at all, the gunpowder will ignite. Now what I've got to do, I'll take my explosives out of the way now, and I'll get some, I think I'll use gravel and put some gravel on top of the gunpowder in the hole. This will confine the gas which is generated and will cause it to exert its pressure for as long as possible on the rock. It's all done with pressure.
Gunpowder becomes Brunel's weapon of choice. He starts by blasting into Box Hill from both ends to speed up the digging. And to accelerate it even more, he also drives 8 deep shafts down through the hill along the tunnel's proposed route. These shafts create 16 extra tunnel faces inside Box Hill, so more crews can attack the mountain from many fronts. But the blasting has a serious side effect.
Gunpowder generates, when it explodes, quite a lot of gas: steam, hydrogen sulfide, sulfur dioxide, and carbon monoxide. Carbon monoxide is intensely poisonous, and if you have several such bangs as this going off in a confined space, that if you breathe too much of it for too long, you will become unconscious and you will die.
Brunel uses a ton of gunpowder a week, which makes the tunnel a deadly place to work in. When Box Tunnel opens, it becomes the longest railway tunnel in the world. But over 100 men have lost their lives building it. Today, at the Gotthard Base Tunnel, the explosives are more powerful and safer than gunpowder. But the principles of drilling and blasting have not changed since Brunel's time. The crew must put their explosive charges in precisely the right place. Otherwise, their tunnel will end up the wrong size.
Of course, there's a real art to drilling and blasting. I mean, rock is not a uniform material. It's got lots of different fracture lines in it and all the rest of it. And you're trying to get a hole precisely the right size, or pretty much the right size. And if you get the charges in the wrong place, you end up taking great big lumps out, which of course is bad news because you had to fill it up and use more material. Or you don't blow enough out and you end up having to blow it up again. And understanding the effect of your charges is quite an art.
But the builders at the Gotthard Base Tunnel aren't going to get it wrong. They have an amazing machine to drill the holes for the explosives. It's called the Jumbo. It has 3 laser-guided drilling arms that are computer-controlled and programmed with the exact dimensions and coordinates of the tunnel. They can drill a 4-meter deep hole in 2 minutes, accurate down to a few centimeters. The Jumbo creates a perfect pattern of boreholes. This guarantees that when the blasters set off their charges, they can be sure to hit the right spot. Back in 1841, Box Tunnel proved that blasting can speed up tunneling, but is also deadly. To drive a tunnel nearly 4 kilometers below the River Mersey without blowing up their workers, tunnelers would have to embrace the power of the machine. At the end of the 19th century, Liverpool is one of the busiest cities in Britain, but many of its workers have a difficult commute. They have to cross the Mersey estuary by ferry. In 1877 alone, 26 million passengers take the slow boat from Birkenhead to Liverpool. What they need is a faster way across the Mersey. So in 1879, engineer Francis Fox and a crew of 700 men begin blasting a tunnel under the estuary.
They're trying to blow a bloody great big hole, and there's only a few feet of rock above them, and on top of that you've got the Mersey estuary. So the blokes start getting a bit concerned about this, and in fact Francis Fox, who's the chief engineer of the job, he comes down every night towards the end of the night shift just to check that everything's all right and the boys aren't getting sloppy, and he comes back one day and he's reported to have said, you know, that they're in a constant state of fear.
Francis Fox's men believe that blasting under the Mersey is a recipe for disaster. The rock beneath the estuary is riddled with faults. The men fear that shockwaves from the explosions could rip open these faults and bring the Mersey crashing down on their heads. Francis Fox must keep up the work, but keep his men safe. So he introduces them to a machine that can bore tunnels. The front of the machine has a huge rotating arm. This is fitted with sharp iron teeth. The teeth bite into the rock and rip out small chunks. As the machine pushes forward, the debris drops onto a conveyor belt and is carried out of the tunnel in railway tubs. To move the drill on, hydraulic jacks lift the top of the machine off the ground. The frame then slides forward and the cycle starts again. The boring machine does wonders for the Mersey Tunnel. It can dig up to 60 meters a week. On the 1st of February 1886, the Mersey Tunnel opens to the public and 36,000 people travel through it. To this day, it is the fastest way to get across the Mersey.
আপনি যদি জিজ্ঞেস করতেন কেউ একটা মাঝ আকাশে বিমান বিস্ফোরণে বাঁচতে পারে?
জবাব, জেনিফার মাকিন নামের একজন মহিলা। কত কিছু জানা, কত কিছুই না শেখার।
আর সব আমাদের মাতৃভাষায়।
ন্যাশনাল জিওগ্রাফিক চ্যানেল এখন বাংলাতে কথা বলবে।
Over 8 million children in the world die before the age of 5. Of these, 2 million children die in India. Every day, every minute, these children die from diseases that are easily preventable. A glass of clean drinking water can help save Girish's life. A nutritious meal for Badam will help her baby live longer. At Save the Children, we know what it takes to save a life. Only 300 rupees a month can save the lives of many children. All you have to do is call on 022-4272-7272 and they will live. It's time we cared. Please, call now. 022-4272-7272. This could be Girish's last chance to survive.
I go the boom boom way. Watch me go the boom way.
रूप तेरा मस्ताना, प्यार मेरा दीवाना।
Now, flip your mood in 4 different ways with Flipside shower heads from Kohler.
हेलो,
क्या आप मोटापे से परेशान हैं? कपड़े टाइट हैं? आपको चाहिए स्लिम सोना बेल्ट? 30 दिनों में
नो
मोटापा
थैंक्स।
वेलकम।
पेश है स्पाइस वीडियो फोन बिग बैटरी के साथ। अब पिक्चर देखिए बिना रुकावट। वेल, ऑलमोस्ट।
When you're in trouble, alone and blue,
Mr. HCL.
just look around. Flight and airspeed help that.
Yes,
and
yes.
I'll be
And
waiting for you. HCL's aerospace solutions help the most advanced aircraft take flight. Technology that touches lives.
लाया तो था शेयर करने पर। Hey, come. Guys, छुपा रहा था।
ओए चौका, उधर देख यार, उधर देख। ये पक्का कैच नहीं पकड़ा, कैच।
अबे वो तो बैट कर रहा है ना।
जब लेस का बिग सेव पैक हो तो दोस्तों से क्या सेव करना, शेयर करो।
Lays Biddle Logical
Launch offer. Get 20% extra with Lay's ₹13 big save pack.
Get away from the concrete jungle. Be the first to experience the Skoda Yeti in the wild. It is your right of way. Skoda Yeti presents the Right of Way Expedition in association with National Geographic Channel. Explore, photograph and learn with a leading Nat Geo photographer. Come be a part of the unforgettable expedition. It is your chance to drive where the roads end. Brought to you by Skoda Auto, obsessed with quality since 1895.
अपने घर जाके देखो मैच। चल।
वो खा क्या रही थी? Dark chocolate inside, sweet sugary biscuit outside. Britannia bourbon.
तेरे दोस्त क्यों चले गए?
बाहर से कुछ, अंदर से कुछ और।
Great service. Great people. Great fares. CX Mobile, now on iPad. Visit CathayPacific.com.
TVS Tires. Ride smart with road sense.
Before the first passenger can travel through the Gotthard base tunnel, the builders need to excavate over 20 million tons of rock. For this Herculean task, the tunnel boring machine has had a bit of an upgrade. It's now as long as 4 football fields and has a cutter head that spans nearly 10 meters. This metal monster can munch its way through 40 meters of rock every day. At the front, the cutter blades scrape the rocks from the tunnel face. Buckets in the rim scoop up the spoil and funnel it onto a conveyor that takes it away for recycling. Behind the cutter head, mechanical arms bolt protective steel mesh to the tunnel walls. A robot then cements the mesh in place with shotcrete. Hydraulic feet shunt the machine forwards so it can keep up with the cutter head. Then workers lay a concrete bed for the railway track. At the end of this production line, the finished product emerges. This machine is the ultimate tunneling tool, even when it comes up against some of the toughest rocks on the planet.
We're now in a granite part of the tunnel, which is one of the hardest and most abrasive rocks. It will dig about 20 to 25 meters a day in this kind of rock, and it will take out 3,000 to 5,000 tons of rock every day.
So tough is the rock that the crew must replace worn-out cutter discs every day to keep the machine going. Digging through granite is a war of attrition, but the tunnel boring machine at the Gotthard is winning.
Without the tunnel boring machine, it would take up to 30 years to dig the tunnel, which would of course be impossible.
Back in 1886, the boring machine used in the Mersey Tunnel made tunneling faster and safer. But as tunnels grew longer, a new problem emerged. To drive the Simplon tunnel 19 kilometers through the Swiss Alps, engineers had to find a way of delivering fresh air deep into the heart of the mountain to stop their workers from suffocating. The 19th century is the age of the railway. Iconic trains like the Orient Express take passengers from Paris to Istanbul in less than 3 days. International travel becomes all the rage. What's missing is a fast connection from Northern Europe to Italy and its popular tourist destinations. But there's a formidable obstacle blocking the way: the Alps. Trains have to negotiate steep and winding tracks to get across these mountains. To save the steep climb, the Swiss decide to drive a passage straight through the base of the mountain at one of its widest points. This means building the longest tunnel in the world, the Simplon. The man who gets tasked with this mammoth job is an engineer from Hamburg. Alfred Brandt knows the horrors of tunneling through the Alps firsthand. As a young man, he witnessed the construction of a tunnel where nearly 200 miners were killed. He realizes that one of the biggest killers under the Alps is poor ventilation. He comes up with a simple but radical solution to his ventilation problem. Instead of one big tunnel, Brandt builds two smaller ones. He fixes powerful fans to one entrance, and 200 meters inside the mountain, Brandt connects the two tubes with a cross passage. Now a powerful draft of fresh mountain air enters one tube and pushes the noxious fumes out through the other. He builds a cross passage to link the tunnels every 200 meters. As the men burrow deeper into the mountain, they seal the cross passages behind them. This redirects the fresh air to the workface. Brandt's men can now breathe more easily. His twin tunnel system is literally a lifesaver. In 1905, the Simplon is finished. It is the longest railway tunnel in the world and shaves half a day off the travel time to Venice. So good was Alfred Brandt's idea that engineers on the Gotthard base tunnel still use it today. Their tunnel also has two tubes linked by cross passages that direct fresh air to the workface. But now there's another problem the engineers on the Gotthard have to solve. As the workers make the 2-hour train journey to the tunnel face, it's like driving into an oven.
Getting hot and hotter in here. That's one of the challenges.
Keeping the workers cool is a top priority on the Gotthard project. The tunnel is baked by heat rising from the center of the Earth. The huge mass of rock overhead traps the heat in the mountain and pushes temperatures in the tunnel up to 45 degrees Celsius. Engineers install 30 huge refrigerators that generate cold air to cool the workers. But the pumps powering the coolers heat up in the process, which could cancel out the cooling effect. So the Swiss use a natural resource to solve the problem.
We use water. We use lots of water. We use up to 1,000 cubic meters of water, of cool water, which gets into the tunnel and which gets through the coolers and which then gets back out of the tunnel to be cooled down again. We devote about half the energy of construction of the tunnel to cooling alone.
The Swiss engineers have built a gigantic web of cooling pipes that reach into every corner of the tunnel. The pipes push cold water through the cooling machines. The water absorbs the excess heat and carries it out of the tunnel. This is the mother of all air cons, and without it, the Gotthard base tunnel would be impossible to build. In 1905, the clever ventilation system of the Simplon tunnel allowed miners to breathe freely and dig further. But as tunnels grew longer, a new challenge emerged. To build a 50-kilometer tunnel between France and Britain, engineers on both sides of the English Channel had to reach a new level of accuracy to make sure they met in the middle. There's one place that has captured the imagination of tunnel builders like no other. 34 kilometers of water separating Britain from the continent. The English Channel. Ever since the Industrial Revolution, engineers have dreamt about connecting France and Britain through a gigantic tunnel under the sea. In 1987, that dream becomes a reality. Work begins on the Channel Tunnel. It will be over 50 kilometers long and lie up to 120 meters below the seabed. The engineering challenge of the century. To build it, the tunnelers must find the perfect geological conditions.
In this little experiment, we've got 3 different ground types, and we're going to see what it's like to tunnel through them. I have here my tunnel boring machine, and I'm going to start in the middle and see what that's like. Now, this is sand, and if I turn the tunnel boring machine on, what I rapidly see is that it's easy to drill through, very easy to drill through, but when you look in there, you realise that it's all fallen to pieces. And that's the essential problem with soft ground. It's easy to move, but it falls on your head. Let's have a go at this one here. This is like a granite. Now, this is a much, much harder material. I was only doing that for a couple of seconds, but already my arm is beginning to ache. And tunnelling through this stuff is really, really hard work. Of course, it holds a lovely hole, and it's not going to fall on your head. It's just really hard digging. So again, not something that tunnellers prefer to dig in. Let's have a look at this third type here. Now my tunnel boring machine is able to fly through this, but the hole is also self-supporting. This type of material is really what tunnellers like. It's a bit like the chalk marl you get under the English Channel.
Chalk marl is a malleable yet firm variety of limestone that is also waterproof. Luckily, geologists find a thick and continuous layer of this dream material under the channel. But the chalk creates a new challenge for the engineers. The easiest way for them to get across the channel would be to start at both ends and dig the tunnels in a straight line so that they meet in the middle. But the tunnel tube must stay inside the layer of chalk, which twists up and down. So the channel tunnel can't be straight. The engineers must constantly change course to follow the chalk layer. Now, making sure that their tunnels meet in the middle becomes a real challenge. Surveying a precise route above ground is easy because the builders can use visual references in the landscape. But doing this underground is extremely difficult.
The basic problem in a tunnel is you can't see where you're going. And so the surveyors have got the devil's own job of following the chalk marl through.
In a 50-kilometer tunnel, even the slightest error will have huge consequences. The surveyors must find a way to stay on course. First, they asked geologists to sink probes into the channel seabed to measure the depth of the layer of chalk. Then they plot a course right through the middle of it. They feed the coordinates to a laser, which fires its beam in the direction the tunneling machine needs to follow. To change course, the surveyors reposition the laser and point it in the new direction. By sticking to this path of light, both ends of the tunnel should meet in the middle. The laser-guided tunneling machine allows the diggers on the Channel Tunnel to coordinate their crews with extreme accuracy. When the two sides meet on the 1st of December 1990, they are less than 2 centimeters out. Now, for the first time since the Ice Age, Britain has a land connection to the continent, the longest tunnel in the world.
Nat Geo always thrills you with the greatest wildlife stories ever told. Always a dramatic turn. A moment of ecstasy. Now witness the greatest wildlife stories ever. All things wild. Always at 8 p.m. and 11 a.m. on National Geographic Channel. Brought to you by Club HP. अच्छा लगता है. The new Fiat Linea T-Jet and BlackBerry.
Do you like bourbon biscuits? New hide-and-seek bourbon. Try it.
इसमें हीरो मर जाता है ना? हाँ? अरे सच्ची मर जाता है. 3 बार देखिए.
पेश है स्पाइस वीडियोफोन बिग बैटरी के साथ. अब पिक्चर देखिए बिना रुकावट. वेल ऑलमोस्ट.
Garnier Fructis Shampoo Plus Oil 2-in-1. A unique blend of shampoo and oil for nourished healthy hair. Now in a sachet.
मैं मनीष मल्होत्रा. Just like me, आपकी भी होगी एक प्रॉब्लम. नए कपड़े ज्यादा दिन नए जैसे नहीं चमकते. पर एरियल लैब्स में मैंने देखा नई एरियल ऑक्सी ब्लू की टेक्नोलॉजी और अमेजिंग न्यू फॉर्मूला जिससे स्टेन्स गायब और कपड़ों में नई जैसी चमक. कमाल की टेक्नोलॉजी, isn't it?
नया एरियल ऑक्सी ब्लू चमक रखे नई जैसी. Experience Disney Tron Legacy. In high definition on the new Nokia N8 with high definition capture and edit capabilities, which also comes with a 12 megapixel camera. So embark on an adventure to remember with the new Nokia N8. It's amazing technology. What will you do with it? Disney Tron Legacy in theaters December 17th.
Reverse the effect of rain. Weather coat All-Guard exterior paint with silicone that actually pushes water away. Truly durable.
Ohio gozaimasu.
I was a tourist guide. What will you do to get your first Android? Micromax Mobile. Nothing like anything.
Caress the senses. Explore new shores. Sip the high life. Grip the moment. The all-new Skoda Fabia. Now, that's fab.
Gesture recognition technology, another way Intel will change the way we live. We are Intel, sponsors of tomorrow.
Through adventure, we explore the world. Through teamwork, we overcome challenges. We rule the waves, excel underwater, soar high in the sky. We are men in white. Warriors of the sea. If you want to experience the thrills, come join the Indian Navy and live your dreams.
On the Gotthard base tunnel, the engineers are wrestling with precision every day. Their tunnel has to curve round to avoid geological fault lines. And when they tunnel through soft, shifting rock, their tunneling machine is constantly pushed off course. This is the man who wrestles with the mountain every day, Carsten Kunze, the driver of the tunnel boring machine.
Wie man es auch jetzt gerade sieht, wir mussten wieder Ringe stellen, weil der Berg gedrückt hat. Die Maschine war leicht aus dem Kurs geraten, mussten zusehen, dass wir die Maschine wieder auf Kurs bekommen.
But deep inside the Gotthard lie nasty surprises that not even steel arches can deal with. In June 2005, one tunneling machine hits a hidden fault in the rocks and gets trapped under tons of rubble. To rescue their precious machine, the builders plan to blast an access shaft from the adjacent tunnel to attack the fault from behind. But they fear that the roof of the access shaft could become unstable and collapse. So they drive in a second tunnel directly from the side. From here, they inject concrete deep into the crumbling rock. This sets to form a solid block and stops it caving in. Now they can safely blast away the fallen debris and free the tunneling machine. With the fault line behind them, the builders are back on track, ready for the next challenge.
Es gibt im Prinzip jeden Tag was Neues. Wenn man reinfährt, man weiß nie, was kommt.
Back in 1994, laser guidance allowed engineers to build complicated tunnels like the Channel Tunnel. Now they could make their tunnels almost as long as they desired. But to reach the final stage in tunnel evolution, engineers have one last problem to overcome. Longer tunnels prove very difficult for people to escape from. So as Swiss engineers drive the Gotthard base tunnel into the mountain, they must also make sure they can get people out. In 2001, the nightmare of any tunnel builder becomes a reality, just down the road from the building site of the Gotthard base tunnel. Two lorries collide in the Gotthard road tunnel and explode. Temperatures inside reach 1,000 degrees Celsius. Dozens of cars fuse together into a molten mass. The fire burns for 24 hours. 11 people lose their lives. The Swiss are shocked. This was considered the safest road tunnel in Europe. Today, the builders of the Gotthard base tunnel know that they must dispel people's natural fear of tunnels. They must make the world's longest tunnel super safe.
There's no use in waiting for rescue in a tunnel like this. The time it takes for rescue troops to get down here may be far too long.
With no time to wait for outside help, in an emergency, the trapped passengers must rely on being rescued from within. The Gotthard engineers rise to the challenge. They build 2 emergency train stations deep in the heart of the mountain. These have 2 rescue platforms connected by a fireproof escape tube. If a fire breaks out on board a train, the driver stops at the nearest station. Fireproof doors slide open so that passengers can enter the escape tube. Now the engineers must stop the smoke from following the same escape route as the passengers. The solution sits 800 meters above the tunnel itself. Powerful fans suck in fresh alpine air and push it down into the escape tube. This forces any smoke back into the main tunnel, away from the escaping passengers, who then cross over to the platform on the other side, a safe distance from the fire. The Gotthard Base Tunnel is almost finished. The men have only 7 of the 57 kilometers left to dig. When it comes online in a few years' time, their tunnel will completely transform traffic across Europe. The train promises to make a huge comeback in European travel and give aeroplanes and trucks a run for their money. But before the first passengers can speed through the tunnel, the workers need to rip millions more tons of rock from the mountain and pour yet more ingenuity into this milestone of engineering. When it's finished, the Gotthard Base Tunnel will become the biggest tunnel in the world, until someone builds an even bigger one.
Nat Geo Weekends is sponsored by Cathay